started now. Now that the herd of people outside the room is gone. So I'm going to give you a talk on R. This is the first time I've ever given a talk on R, even though I've used R for about 15 years. So that's surprising to me. but it was fun to make this talk, and I'm glad I did it. My name is Bryan Comstock. I'm at the University of Washington. I've been there almost 15 years now in my day job. I now have a new night job at CSAT.com. I helped co-found that and work there with Adam, who will be doing this shortly. So I'm going to give you a talk on basically the background of R. I'm going to give you a talk about what biostatisticians do, because I think that's a helpful sort of framework to get you acquainted to why I use R and know R. And then I'll actually get into R probably about a third of the way here. And we'll learn some basics. 90% of R is like things that unless you're a statistician, you might not ever need or use. But R is pretty powerful, just again, for general uses and interactions with data. So before I get going, I want to know how many people have opened R before?
Opened R?
Opened it, yeah.
Opened it. I opened it immediately.
How many people are R users? Why are you in this class?
Getting paid.
Okay.
Check it out, because I'm actually, I tutor people in R and have been trying to teach colleagues about it to get them off of the sucky package for statistical software.
That shouldn't be a hard, usually those two people are like perpendicular, right?
Kind of.
Okay. So for those who know R, I'm going to go over the basics, like the things that if you're going to open R and start to use it, you'll need to know them in order to sort of be the basic proficiency. I'm not going to go into generalized linear models or anything statistical for that. So a bit about me: I've got a master's in biostatistics. I've been at the U for about 15 years. So the irony, whenever I write this line for a presentation, is I chose not to get a PhD in biostatistics primarily because I don't like to give presentations. And now I do this regularly, which, again, I have to say that every single time. The core of what I do in my day job is I design and implement randomized controlled clinical trials. So, we'll compare two or more treatments, and here are some examples. So basically, testing a drug called EPO. This is a drug that Lance Armstrong got busted with. We're giving really high doses to really premature babies to see if that helps them live, helps them have better cognitive development later in life. Most recently, we just got done looking at whether or not you should have steroids put into your spine if you've got a condition called spinal stenosis. Don't. And then we're starting to work on another study looking at cognitive behavioral therapy for people with advanced stage renal disease and who are very severely depressed. So these are sort of like design the study, execute the study, analyze data from the study, and so basically in all of these studies and others, I use R to analyze the data in those studies. And before that, it was S+. So most recently, I helped co-found this company called CSATs, and I think I'm going to use some data from CSATs to sort of help motivate and illustrate some content on. And that stands for Crowdsourced Assessment of Technical Skills. If you have questions about that, talk out. So about biostatistics, when I tell people what I do, sometimes they've never heard that word before. They've heard the word statistics before. And so basically, biostatistics is the application of statistics in one of these fields: agriculture, biology, genetics, medicine, pharmacy, public health. And the goal is really to answer questions of interest. This is a kind of it's a funny cartoon for biostatisticians, probably not funny to anybody else, so I won't show it to you, but you're welcome to look at it later. And basically, I refer to my role as like the data police. I prevent good people from doing bad things with data. And the researcher here in this video is basically approaching the biostatisticians as a service and saying, am I well powered to test drug A versus drug B with 3 people in each arm? And after 3 minutes of arguments, the biostatistician just says, go away. I've done a lot. So I asked Adam a funny question the other day. I'm like, would people get offended if I brought in a PowerPoint presentation to this conference? And I thought the answer probably was yes. And so in the spirit of that, I learned a new R package that I hadn't learned before, just to present here today. It's called R Markdown. Basically, all of this content here that you see, I did in R to make this slide deck. So as a part of the first time opening a R Markdown package, you get this little information, and off you're running and go. It was really easy. So the caveat is that it might be a little clunky in places. I'm definitely PowerPoint oriented, and so it is what it is. But it was really easy to put together, and I'll probably continue to use this format going forward. So my goal today is to provide you with content, so that after this, if you actually do, for those of you who don't use R, you could actually get started using R after this. My second goal, and this one's where I have to tap dance a little bit, is I'm going to teach you a little bit about a statistical computing package without teaching you statistics, which I think I can do, but I'll try to stay away from statistics for the most part. It's hard. What I won't provide probably today is a relative comparison of all the other tools that you might have available or use. I will get into a couple of things at the end. I do use other statistics packages other than R, but 90% of the time it's R. All right, so here's an outline for today's talk. We got like 70 slides or whatever. I'm sure I can get through them. So basically, I'll give you a history and a background about R and where it's at today, where you can find it. I'll give you some basics on basic commands that you probably need to learn in any programming language. And then I'll go into some basic graphs and reporting and statistical analysis, real baby statistical analyses. And then I'll share with you a slide on advanced features, which I think are super cool, but I think beyond the title of this talk. And then I'll give you some instances of where I go when I use things outside of R, such as moving or NLP. Maybe some concluding thoughts. All right, so history. So to tell you about R, I have to first tell you about S, which is a language that was developed back at Bell Labs in the mid-70s by John Chambers. It was like one of the first statistical languages that they were really trying to make accessible. And I think, over the course of a decade, they did make it accessible to a point where somebody else wanted to commercialize it and try to sell it as S+. So in the mid-1980s, a group called Statistical Sciences formed, and off they went and tried to license and sell S+, and they did so for a long time. You can see that it's changed hands over the years, most recently to this TIB code. So in the mid-90s, R began as sort of an implementation of the S programming language by two guys, Ross Ahaka and Rob Gentleman, who was here until recently at GNU and the Hutch. And it really began as sort of a grassroots campaign to get a free statistical software package. And it really got a lot of support as the functionality grew, and as departments such as statistics and biostatistics departments didn't want to pay for lots of S+ licenses for their students. So where you can find R today is at CRAN, the Comprehensive R Archive Networks. It's cran.rproject.org. There you can find Windows, Mac, or Linux versions. You can run R from the command line, either through Emacs or Terminal, or you can run it through a limited GUI. It's a programming environment that uses a pretty well-developed but simple programming language. It allows for the development of new tools, and users can actually create new libraries and new packages and have them accessible pretty easily to other people. And stop me if I'm just blowing through things that you want to talk about. So that package library, so this is a screenshot from CRAN. It gives sort of a glimpse of, the first part of the glimpse of the 5,800 plus packages that are currently available. Available either through the web, you can go to the web and click on one of those and get it, or you can get it through the graphical interface. There are 120,000 functions in those 5,800 packages, and again, it kind of comes with a caveat, sort of buyer beware. I've got 2 packages up there, and they work great for me, but they might not work at all for you. And you'll see that, and with a mixture of sort of documentation as well on how to use them. So I've gone over where you get R. I'm going to talk a little bit. So I use RStudio in the last year or two. I use this sort of a wrapper around R that basically provides more of an integrated environment. It provides you with an editor, provides you with again sort of a panel display where you can see what your script, your output, your plots, your history, etc. I think it's a really nice environment to use if you're going to use R with a graphic interface. You're not really meant to read any of that, but that's what it looked like when I was making this presentation. So I tried to find stats, like how many people use R. So I think half the room sort of said, yeah, I use R, or I do use R. The stats are limited out there. The last count that I could find was 2009, where there were 250,000 plus users who use R regularly. And they span the gamut from biostat to statisticians to computer scientists, engineers, data analysts, industry, Google, Amazon, pharmaceutical companies are starting to get a little R penetration, academia, graduate students. And R is great, but it has a pretty steep learning curve, I would say. And I don't know if anybody agrees with that, but I think especially for statisticians who don't program as their sort of primary occupation, I think this is it's a rude awakening to statistical computing. I haven't seen R penetrate medicine at all. Only a couple of rare examples who are sort of have a bachelor's in computer science and then go on to get an MD. They might use R, but it's hard, I think, for your average doc. So here's a different way of looking at who uses R, and I don't know if that you can see that. I can see that. This is basically the number of Google Scholar hits for each type of software by year. So these are citations to statistical software package. So there's a whole host of these little guys at the bottom, and then there's 2 monsters up there, the 2 gorillas. So the top one is SPSS. This green guy is SAS, and they've got a disturbing bell-shaped curve. I'm sure it's disturbing. Yeah, that's the kind of bell-shaped curve you don't want. So if you just look at the little guys, this green curve right here is R, and really it sort of, again, you can start seeing people wanting to cite it in the sort of 2002 to 2005 range, and I remember in that range using R and wondering, if I cite this in a manuscript, am I going to get dinged? And is somebody going to not think this is credible because I'm using not SAS, I'm using not SPSS plus. But clearly it's been gaining traction and acceptance. So I'm going to get into R now.
Yay.
So my titles are at the top, so I'll say the titles and then you can look at the bottom. So basically these are things that you need to know. So the first thing I would want to know if I was going to learn a new package is how do I comment things out? What don't I want to run, or which swath of code am I going to need to just not run ever, but want to retain for some reason? A pound sign, a hash, 1, 2, all of them. Anything that follows that is a comment. So basically, that first line is not executed, and then this one is, and the output stuff comes to the cluster. The next thing I want to know is what certain programming languages won't run unless you've got a semicolon after them, or unless you've got the proper structure. Basically, you can do inline commands that are separated by a semicolon, or a new line will run. All right. So you can either run commands interactively at the command line by typing them in and getting the output, or it can be a really interactive process environment, or you can just source a file, basically a string. So since I brought up my first R function source, you can get help on any R function by typing question mark source. and it'll bring up a little page that is sort of a standardized help menu. And again, depending, anything in the base suite of R is pretty well documented. Anything outside of those user pattern cases varies. So R stores both data and output from data analysis in objects. Object assignment is facilitated by a left one arrow or an equal sign. It's both do the same thing here. So basically, answer 5 with a little arrow. 2 times 2 plus 1 is 5. Variable names can be long. It's another variable, an object that I'm labeling, and that is also 5 with an equal sign. And I also put in a little thing about order of operations can be enclosed with parentheses. Rules around object assignment are basically you can use letters, numbers, dots, underscores. They must start with a letter or a dot, but if it's a dot, you can't have a number after that for some reason, and it's case sensitive. There's rules. So two more functions that are like, again, the core things you ought to know. Print will print any object, and so if I want to print answer 5, the variable names can't be long, it'll do that happily. It'll say they're 5 and 5. I've also in that statement is this thing. This is probably, I would call this the most used function in R, and that is C. So C it's a really common function, and it basically combines values together to form a vector. So here I give you an example of C where I'm pasting this bit together with 6 and 10 in this bit. And these 2 bits are both the same way of getting at a sequence of numbers. 1:5 will give you 1, 2, 3, 4, 5. Or you can use S, E, Q. And then you get the string. So the vector. All right, so I told you a little bit about libraries. So this is one. Yeah. What was the one? Oh, did I not? Oh, pi equals 1. Oh, this guy. Yeah, that's our output. It just says that was the first line of the output. Okay. Yeah, no, nothing that I put in there.
I think it's the first item, actually.
The first item.
So yeah, if there was another line there, you'd have another one in brackets, and it would be like 19 or something.
Yeah. All right. So if you want to add a package, if you want to go and grab the survival package, you would do that because you wanted to do a survival analysis set or the biostatistician. And you could do that by calling library parentheses survival, and it will basically go load library into where it can access it, and it'll go and get any other packages that it needs in order for survival to function. I'll give you 2 more examples. So HMIS is one of my favorites. So anytime I write an R script, I like to think about all of the packages or libraries I'm going to include, pick them up at the top and set them in. This one I always cite is just a random mishmash of functions that are all useful. They're all developed by this guy Frank Carroll at Vanderbilt. He's the chair of their department there, and he just put this out and just been having students like add to it over the years. And again, they have a lot of useful functions. And then for this talk, I'm not going to get into ggplot yet, because ggplot is sort of a new plotting paradigm, I would call it. It's a new way of plotting. I think plotting in R can be intimidating. R is a very, very powerful graphics package. It makes very good graphics, but you have to spend time and effort to get them there. ggplot tried to, I think, simplify R's graphics. So this is my first time using ggplot after the kids I see come through our department started using it. What's this? What did I learn about this? All right, so you can get that by ggplot too. I don't know what ggplot. Yeah, no, but I don't know why too. So basically, you're going to use R to operate on data. You need to get data in. I'm not going to just make up data. I make up data a lot, but I'm going to operate on real data here. So R is most happy to get data through a text file. it'll take tab separated, space separated, comma separated file really easily, really happily with this read.csv function. There's a read.table function and read.delim. They're all sort of variants of the same thing. There are functions in the foreign package that allow you to directly import data from other statistical software packages. So you can get to some extent. Stata and SPSS files go in pretty readily. SAS less so. But yeah, there are a whole slew of these packages. This last year, I was exposed to another package called XL Connect, where it allowed me to go into a messy Excel file with lots of sort of nice headings that looked beautiful to the person when they were entering data into it. But I didn't want to have to go. I get tired as a statistician of like trying to rip out all your columns and all your fancy rows. I just want to get right here. And that package will actually let you get right there and zoom in on a certain Excel part of the Excel file and just grab that out of data, which I thought was good. Right. And then the last way I get data into R, I can get it through the web or through an API. So if you have data in some database and that database has an API, you can go in and rip it right out through this post form command. So I do that with this package called RedCap, which probably you haven't heard of, but it's basically an online database for capturing data prospectively in graphical files. That's really handy. So you just need like a little secret code in there. So I put a bunch of like little options in there. You get the secret code and you're in business. All right. So I take a break. I read in a data set. I read in this data set during that last set of slides called All Data. And All Data basically come from a recent project at CSAS. I can tell you which one now. Where random crowd workers and experts watched and rated 21 videotaped procedures of laparoscopic robotic surgeries. And they basically use a common rating scale to rate across this 4 domains: depth, perception, and these are robotic surgeries. So they're unlike the Da Vinci robot, like cutting things open and doing gross stuff. And depth perception by manual dexterity, efficiency in tissue handling. This is sort of what they would call a validated set of questions that have been developed and used over the years. And it yields an overall score of basically 4, which is bad. You don't want to get a 4 or a 20, which is the best you can get. And really the goal of this particular data set was to compare expert ratings, which ended up being 5 per video, with 5 experts reading these videos. We had over 30 crowd workers read these videos. We want to see like how comparable was that. So that was just the motivation for all of the rest of the data that we'll be looking at. And I'll pop in and out of it when necessary. So now that I've got data in, there's a number of ways, lots of ways for you to actually go and view it, look at it, which is something you ought to do anytime you're going to start operating on data. So our data sets are stored as data frames. So all objects are a data frame, and they have like a matrix structure. So again, where the observations are delineated by rows, and the number of variables are columns. So that's a basic structure. That's what R expects. And the indexing is basically object, the first rows in the first position of the matrix, and then column. So one useful command that I like to use probably very frequently throughout the course of the data analysis is like, oh yeah, what's in my data set? Names will get what's in your data set, or at least I'll get you what are the column names? What are the things that you can access? So I've got a bunch of things. I've got a bunch of IDs. That ID, the person, the video that I'm looking at, the file name, some ratings, some text, some dates, some timestamps, and then basically, the meat and potatoes, which are these last 5 things here: depth, efficiency by manual, and then the overall rating. If you want to get sort of like how big is my rectangle of data, dim will do that. Dim is for dimension. It'll say basically you've got 767 rows and 22 columns. Again, another helpful thing. One of the things that R will allow you to do is get yourself into a lot of trouble when you've got multiple data sets open at the same time, and they're similar enough. and you've been creating data sets, and then you want to know, well, how big is that data set that I just created? Because I've merged 5 data sets together, and you find out it's got 0 rows, and then you go back, and you find out it's got 0 rows by doing a demo on it. You need to did something wrong. Another way that I've learned recently is you can use this thing called head or tail. You can sort of take head of the all data, and I'm just looking at columns 18 through 22 here. Again, this would get too messy and big. And it'll give you the first 6 rows of that matrix. Tail will do the same thing except for the last 6 rows. Another useful tool is well, actually, so before I get into that useful tool, you can get at specific variables in 2 ways. So if I want to look at the overall rating, I just want to look at that variable. You can get at it by, I'm going to plot out the first 10 elements of rating by going all data, and look at these rows 1 through 10, and which column. I can either call that out as column 22, because I know it's column 22, it's the last one, or I can just say it's rating, and it'll go and find it independent of where rating is in the data set. Or you can use this little $ bit. So all data $ rating 1 through 10, which is the same thing.
So indexing starts with 1, not 0.
It does not start with 0. Oh yeah, I didn't even mention that. Just a little
tidbit there, yeah.
So it assumes the first line is the headers.
In the first line,
That's how this works.
the first line is part of that.
Or like, okay.
That's funny. All right, so dates. Yeah, I'll get into it in a second. All right. So dates are a pain. I don't know about in other packages or other software that you use, but in R and in all statistical packages, dates are a pain. I don't really mean to go through all of these lines here, but just to say that anytime I get a date from you or from anybody else, I generally have to dissect it and put it back together in a way that R is going to understand that it's a date. It's getting better, but it's still a pain. So, usually what I'll do is sometimes I'll get dates like 10/24/2014, and R will just think that's a string for some reason. And again, maybe I could be smarter about specifying that up front. But usually I've gotten over this now, and I just split it up, paste it back together, and call it a date. That's the point of that slide. Just beware.
What if you're using talk time?
What's that?
You're using talk time? Just give it 2 seconds. Just give it 70. Just use that sort of line.
Yeah, no, R will do that automatically for you sometimes. I don't know if it's second. R, if you will sometimes, you import a data set and it sees something that looks like a date, it'll just say, oh, that's the number of days since 1960, something like that. It has some sort of internal thing, but I'm not a Unix person, so I don't, that's why. That's probably why. R will allow you to define functions on the fly and use them right away. You don't have to do anything. I used to program in C like a long time ago, and I always remember all the declarations and crap that you had to put up front. R doesn't really have that. So that first line is an example of a simple function I use to work with strings. It's basically sometimes R likes to put things into like levels, and I don't like to use things as levels, so I unlevel them or I delet them. And then below is an example of a more complicated function that I use to get like confidence intervals. So you can make them simple, useful, or complicated and useful. All right. Before we get into like graphing and statistics, you can write out data with write.csv, opposite of read.csv. And there's, again, as with reading in, you can write out data sets of different types as well. Looking boring. All right, so now that I'm sort of past like some of the sort of base functionality, summary is a useful command. Summary will like take any object you throw at it and you say summary on top of it. It'll try to do something. So with numeric data, it'll try to do things like this. It'll try to say, basically, I'm going to give you the min through max and then a bunch of percentiles about the distribution. I'll give you mean, basically, I'm summarizing the last 5 columns of data. you can add in this subset bit right there, right in front of subset summary. If you just want, I want to get a summary of the people who are the crowd. So I just want the crowd numbers. So where group equals crowd, I'm going to get a summary of that. So again, this is another way of just quickly sort of like looking at summaries of data by subgroup.
Group is a column.
Group is
You're
a
saying
column.
when that column has the value crowd, that's right.
Yeah. Yeah. Another point. Equals equals. Since equals already sort of has a purpose, which is sign that. Equals equals means like comparison or sort of where this equals crowd. Semantic. Okay. All right. So I'm going to get into the GGs.
I just found out about GGL.
I need to do more work with it. So what did I do? So if you want to look at like bivariate data, so this is really crappy data to be looking at GG pairs. But if you had more interesting data, this would be one way to do it. So you can get this function out of something called GNU+Linux, and it basically GG pairs, and then it just says give me this data frame, and it'll plot all bivariate comparisons and give you the correlation coefficients if that's new for you in here as well. Actually, that's actually useful. So, otherwise you have to sort of specify those one by one. So this could actually be a really useful command.
Well, I don't understand any of this part. What are the?
You're not a statistician. So basically, I've got depth, and I've got bimanual dexterity efficiency, and something down here, tissue handling. And each of those has a 1 to 5 rating. And I basically want to see, like, is the depth rating correlated with the bimanual dexterity rating? And that would be sort of given by this guy right there. That's the plot. That's the bivariate plot. So for each video, they've got, you might have a 1 for depth, you might have a 1 for bimanual dexterity. It might change, but the correlation between those two things is pretty high. You don't need to know what correlation coefficient that is or whatever.
Meaning, do the depth, do the numbers for depth correlate with the numbers for bimanual dexterity?
That's the simple interpretation. Again, not a super like useful example here. This isn't like my main question of interest. I'm just illustrating one way to look at it.
And what is this dot, this visual thing?
The visual thing is a product of the variable that's in there. It's categorical. It's 1, 2, 3, 4, 5. So if it were not 1, 2, 3, 4, 5, say it were like BMI and something else, age, it would look different. It would look like a cloud of things. Bad, cool function, bad data.
Okay, you have 5 discrete points.
That's right.
It would be depth, maybe 1, 2, 3, 4, 5, and that's it.
That's correct. All right. You can look at. Okay.
Oh, no, all right.
Okay. So ggplot is again this new paradigm for plotting. And so you can plot things called like histograms or density plots with ggplot. You can do a bunch of things with ggplot. And basically, I think the thing that this ggplot adds over plot, which I'm going to show you in a bit, is like it just allows you to like add on, like it defines something called geom density. If you just add that on to this plot to the left, it'll say I'm going to draw a curve that looks like that. And that's basically like, again, like if you think about it as a distribution of the values of for the crowd workers on the left and experts on the right on the overall rating. Yeah, don't read too much into the data. So this is the old school way. This is my way. Well, of course. But it took a lot more text to get it effectively the same thing, which is why I think ggplot basically has come to sort of fruition. And again, I don't intend to sort of go through each of like the little options in there, other than to say that there's this other useful command in R, which is probably the second most used command for me. If you're actually going to plot data in R, you need to become friends with PAR, P-A-R. And it comes from sort of like parameters. But basically, there's over 70 graphing parameters that could go into tweaking a plot, which is both a blessing and a curse, because you can create really rich graphics by tweaking these parameters. But then, if I need to know how do I rotate the axis labels or whatever, you just have to either know or dig in. Anyway, it's a pretty good help file. So, all right. So really, the purpose of this data set was to look at does the average crowd rating, is that in any way correspond to what the experts might say? And we've got multiple ratings over these 21 videos. So we've got, again, 5 expert ratings. We have over 30 crowd ratings for each video. And so really, I actually don't want those individual ratings because I don't care about them. You need like your average perception across the ratings through a mean. So there's again a lot of ways to slice and dice this. One way to do it is to split them up. I'm going to take all the crowd ratings, put them into this object called crowd ratings. Take all the expert ratings, put them over here into this expert ratings object. Again, so I split them up by group.
The same survival data is all up group.
Yeah, so basically subset here is I'm taking the entire data frame, the entire matrix of data, and I'm splitting it into 2 parts. I'm taking the rows where group is equal to crowd and putting them in a different data set. I'm taking the other rows where group is equal to experts. But so it contains both the rating and it contains all of the other data. I could have just taken out the rating and done this as well, just because that's really the one single value I'm interested in. So this is a bit of text, but really I think the point here is that there are like 3 functions that go into doing this. And so one is by function. By is another really useful R function to know, and it basically says take crowd rating and by this video ID record, where video ID is the thing that flags which video are there. So there's basically, you can think of it as an index of 1 to 21, and each video has 1 through 21. It's an ID for the video. And take the mean, and it basically goes out and says all the videos that are labeled as 1, take the mean and grab it. All the videos that are labeled 2, take the mean and grab it. And then I throw in this as.numeric, just sometimes R gets confused. It doesn't always fit into numeric, so just make sure that it does. And then I round it to a single decimal place. You don't need to do that, but it's a bit better. And then basically, you can see that I print the crowd mean here, and I've got 21 values there. I print the expert mean here, and I've got 21 values there. So now I've got something that I'm interested in. I've got the average rating for 21 videos for the crowd, the average rating for 21 experts. So from the experts on 21 videos.
So you have 21 values out of those 21 videos?
Correct.
And how do you know which ratings, which of the outputs map to which video?
Yeah, so by does things sequentially, and I know that video. So yeah, there's definitely some nuances to making sure that 13.8 corresponds to the 10.2. Like, don't sort these. That would be bad. It would be like a bad Excel sort where you just completely messed everything up. It's in the by statement. So if I had taken out the as.numeric and I just said give me by, you would see that it goes video 1, 2, 3, 4, 5, 6, 7, and so on. So I glossed over that.
So video ID is an integer.
Yes. Video ID is an integer. It would do the same thing. It would try to sort it. It would sort it by however, and it would sort it again if you're looking at the same videos in the same way, it'll sort it in whatever way it thinks is natural. So again, if it's like video file name, which I didn't do here, that is like a string, and it'll try to sort it alphabetically. And if you're worried about that, there are other functions that you can use to make sure that you get a one-to-one mapping. All right, so I wanted to go here next. All right, so here's my one statistic slide. I didn't want to do any, but so this is. But I wanted to show you again that you can map a statistical analysis into an object. So basically, model 1 is that first line code, and I'm going to basically, what I want to do is do a standard sort of linear regression model. And linear regression model is specified by LM. And effectively, I'm regressing the expert mean using the crowd mean to predict it. So basically, I'm fitting a line to the data, and I'm going to show you that in a second. And here's an example of, you do summary on that model, summary that command again. It'll plot out a bunch of things that you don't need to know about if you don't want to. But I'm really key in on again, statistician me. I key in here, and then I key in like here in this range. This sort of tells me like the relationship, and this tells me the strength of that relationship. And again, I don't want to talk about p-values.
What's that?
Yeah. Oh, that's a good, yeah. Tilde. So basically, that is the operator you use in any sort of model. So any statistical models, basically, the left-hand side is like the thing that you are, what people call like your outcome, the thing you're looking to predict. Tilde, and then it can be followed by a sequence of other variables. So I could have added in a plus video length or something here as well. And that would basically say, I'm going to look at my expert mean as a function of crowd mean. I'm going to adjust for the video length. I think video length matters. It does in these cases. Longer videos are worse. But yeah, good question. So the tilde is basically like, means expert rating is a function of crowd mean. So in that same vein, here's a different way of looking at it. So this is basically a plot. I'll show the code real quick. So plot is a very useful command if you're not at a ggplot and you use plot. And it basically is plotting the expert mean against the crowd mean. And that is what would be called a scattered plot of the data.
Do you have X and Y limits? Would it automatically calculate that?
It would, and yes, it would.
Does it not do it very well?
No, it does it within the range of the data. So, like, if I had a couple of different data sets with the same outcome measure, so say I had in this data set of 21 videos, 10 of them were junior residents that were just learning how to use the DaVinci robot, and 11 of them were senior faculty experts that are just the bomb on a DaVinci expert robot. What it'll do is you'll see the same cloud of points. You can plot one here and plot another one side by side. You'll see the same cloud of points, but without specifying the limits of the axis. This cloud of points will be at the upper end of the limit, and that cloud of points will be at the lower end. So it's a visual miscue in my mind. So I try not to do it. I try to always sort of give the limits.
So it's pretty tight around the data.
It does, yeah. I don't know what it uses as tolerances, but it always tries to like zoom in on the data where the data are the most. So if there was a really big outlier here, it'll zoom out all the way, and you'll see like a big, tightly clustered cloud of points and then a huge outlier. So plot will allow you to just start adding things to it. So basically here, I'm adding in, so it's the same command up there, and then I'm using this command called AB line. AB lines, you're going to add a line with an intercept of A and a slope of B, and that is created from that model one that we just fit a little bit ago. So basically, I took those coefficients that I pointed you to, and I said, here's the relationship. That's the product of those coefficients. So I can overlay that pretty easily onto this plot. I can overlay other things too, as many as you want. Again, you can make these rich. So you did like a little smoothing spline through the data with lots of degrees of freedom or whatever, and make the colors on the plot, the points pretty. All right. And then basically, R has the capability of writing that out. That's all. So you can use this command called PDF or any number of other commands. I like PDF. You can use something with JPEG or PostScript as well. Just remember to turn it off. It opens up a device and you've got to turn it off. How am I doing on time, Adam? When should I stop?
3 minutes.
I got 3 minutes? Okay. So So I've got like these, so I'm not going to go into each of these functions maybe, but again, if you're interested in seeing this again or something like that, these are the 10 that I use almost every single script I write. CBind sort of binds things together. It takes this matrix and glues them together. It doesn't care how. It just says if they're the same number of rows, I'm going to switch them together. Text allows me to add text plots. Paste allows me to glue things like a string called my son is, and then the answer 5 from a little bit ago. So it returns my son is 5. Merge, we'll try to more smartly merge two data sets together by a common variable in each of them, like ID. Match and which are sort of two different variants of select statements or subset statements. Table does exactly that. Tables. Apply is R's way of getting around loops. I'll get into that in a second. And then length and is.na. Is.na is a fun one because it just basically says is something missing or not. So R uses NA to signify missingness. Some advanced things in R that I wish I could talk. That would be like talk 2 if I did it. Maybe you can invoke C scripts if you have them. I wrote my thesis using C scripts that I called from R. Why? Because they were available. Because I didn't want to rewrite what was in the C scripts in R, and so use them. Use that. And again, C is much better at looping than R. There's a huge push toward reproducible research, and R Markdown is one example of where I'm like interactively acting with data, and you're seeing it. And there's a couple of other packages as well. And then finally, Shiny is this cool new package that we've been playing with a bunch, and it allows you to sort of interact with the data versus in plots versus just providing static images like I just did a bit ago. So a few things. When to look outside of R, loops and NLP. So this is just an example of the same loop. It's a while loop. Basically, it counts 5 from 0 to 100,000. And then it's got this thing buried in here, 10. It's not doing anything. It's just sitting there. It's not doing anything. But you add in a bunch of these parentheses, which also aren't doing anything, and this takes about 2 times as long. Well, it did on one run. But it's been averaging between 2 and 2.5 times as long, just to add those parentheses. So it's really, because it's an interpretive language, every operation carries baggage, and so big data sets with complex loops get bogged down. So basically, there's a number of options. You can use these apply or variants of apply to, or do smart matrix algebra. If you're a matrix person, you can do a lot of things with matrix algebra. Otherwise, you can pop into Python and run a function and do the looping in Python and call whatever it is that you want to do. Or you can just wait, which is what I often do. And we'll get into NLP other than to say that there are better tools for NLP. Yeah, so other packages. So you mentioned SAS. SAS is like the other sort of popular package, not in academia so much, but it handles big data really well. It's well accepted, but as you can see with the bell-shaped curve, it's being less used, so that's a good thing, right, in my mind. R's graphics are still superior, even though SAS's are starting to improve. And then, yeah, there's a whole bunch of other packages out there that I use infrequently, but they have nice features as well. It's always good to have multiple go-to packages for various things. And again, a lot of these just vary by what discipline you came from. And I made a lot of generalizations there that are probably unfair. Yeah, so again, I don't use Python that much, but it's great as an augmenter. A lot of people I know use it in conjunction with R. So basically, I think I'm done now. So R it's a robust tool. It's got a steep learning curve, but it might be useful if you've got a good programming background or you're a statistician and you want to analyze data regularly. And there's piles of help out there, but it does feel, when you're first learning it, feels pretty like an onerous task. If you Google your question, the answer is almost always there in the first page. And then again, there's a listserv with a bunch of snarky, cranky old men that will respond to you. Just watch out. How you say it. I think that's it.
Someone sent a message to the R help list the other day, and CCDSR for some, Eric has Rangin for some bizarre reason, and some stuff.
It gets spanked. It gets spanked
A little.
a lot. I go to Google or Plus.
Yeah.
Any questions?
Quick one, can you manipulate data in more than 2 dimensions? Like X, Y, Z?
No.
Yeah, okay.
Not really. I mean, no, abstractly.
Kind of abstracted by throwing a whole bunch of data frames into a large list and
Yeah.
then deal with it that way.
Oh, you gotta do it kind of yourself.
Yeah.
Okay.
It's not, not out of the box. You have to do it abstractly.
No library Z-plot.
What's that?
There's no library Z-plot.
Z-plot? Probably. Yeah, the bottom.
Do you know if it does decimal math? I noticed that 0.1 plus 0.2 is 0.3, which is in Python it'd be like 0.30 because it's floating point error. Do you know anything about that?
It doesn't do that. No.
So it rounds for you or something?
Well, yeah. I mean, I will round things, but yeah, I guess it won't give me a bunch of trailing zeros.
Okay.
If there's nothing out there specified, it won't give it to you. So it'll give you as much precision as we put in, except for like when you're getting like, say those coefficients. I forget how far out they go. They go out of range. Yeah, so like yeah, but like, so isn't there this little add-on like NumPy or something like that that's been gaining more and more sort of statistics functionality?
There's a package called Scikit, which has actually syntax really similar to R, and it has its own GNU plot. Yeah.
Oh, what?
It's called Saudi because you need more.
So obviously, this is like so many sides of the screen. If I just talk a little bit about that down, this is more thorough.
Yeah.
So I know like other tools that
I didn't want to. Yeah. Yeah, I don't know. I don't know what to tell you.
it's completely not functional.
Yeah.
Nothing.